Sound fully better. So recording for it.
Circular motion. Just a minute, Hemant. I'm converting the file into PDF. Yes, Hemant, I have sent you the file via WhatsApp, okay? Please check if you got it.
I got it.
Is the screen visible? Yes, now.
Sir, it's a screen is visible.
Okay? Now, circular motion. What is circular motion? What do you mean by circular motion? See, circular motion will be said only when the particle is at a fixed distance from a fixed point. That fixed distance will be called radius, and that fixed point will be called center of the circular path. Okay. Now in circular motion, if a particle is covering some distance, let us say that distance is from A to point P. Okay, particle started from A and reached point P. Then what will be the displacement if it covered angle theta? See, in circular motion, each and every instant the direction is changing. The direction is changing continuously. It means what? Each second vector is also changing. Each second vector is also changing. Position vector is changing. Getting it? Each second velocity is changing. So for that, first of all, we need to find out the displacement. How can we find the displacement? We can find the displacement by using triangle law of vector addition. Delta R is our displacement, and R2 minus R1 will be delta R. So what will be the answer? What will be the displacement? Displacement will be, see, 1 minus cos theta we are writing here, 2 sin square theta by 2. Hence we are getting under root of 4 r square sin square theta by 2. So what is the displacement in circular motion? Displacement in circular motion is 2r sin theta by 2.
That P and also displacement. Circle.
From A to P, AP is the displacement.
Pop it. Sir, copy.
Copy. Now, so displacement of the particle will be 2r sin theta by 2. Now this is the displacement in meters. It is delta r. What is the angular displacement? Angular displacement is the angle theta itself. Whatever angle it is covering, that is the angular displacement. It is delta theta. Means difference between the angles theta 2 minus theta 1. Take it down. Angular displacement.
Sir, this 2r sin theta by the linear displacement we need to consider.
Yes, that is not linear. That is not the length of arc. This is displacement. Length of arc is different. Length of circular arc, which it is covering on the periphery, that is different, and this is different. Okay.
Sir, this PA we can say linear displacement we can say, sir, before.
Yes. Displacement is always linear.
Sir, means that length of arc is the linear distance travel we can say, the distance.
That is linear. That is linear distance. This will be the displacement. And when we are saying displacement, then it is always linear.
Sir, copy it, sir.
Copy. Yes, taken down. Next is angular velocity. See, angular displacement is there. It means the rate of change of angular displacement will be there. And what is the rate of change of angular displacement? That will be called angular velocity.
Same as linear velocity, average velocity we can say.
Yes.
Sir, copy it.
Copy. Similarly, we can write instantaneous velocity. Instantaneous velocity will be what? Differentiation of displacement, angular displacement theta with respect to time t.
So at that particular instant, the rate of change of angular displacement we can say.
Yes, that is angular velocity.
Sir, copy it, sir.
Copy. Now see this question. If the angular displacement is this much, find omega.
Sir, angular velocity called axial vector, sir.
Angular displacement will be angular displacement, angular velocity, angular acceleration. All are axial vectors. Why? Why they are called axial vectors? We have already seen that in vectors when we studied basic mathematics. Because their direction is always taken by right hand thumb rule. Okay, in the direction of rotation, just rotate your fingers Curl your fingers in the direction of rotation, and the direction of thumb will give you the direction of angular displacement or angular velocity or angular acceleration. Taken down till this point?
Different. It's a copy, sir. After that.
Copy? Fine. Next is time period. Time period is nothing but time required to cover one full revolution. Similarly, frequency is what? Frequency is number of revolutions in 1 second. Okay. In 1 second, how many revolutions are completed? Divide 1 by capital T. We will get number of revolutions in 1 second.
Sir, even means per unit time we need to define now.
Yes, what did you say?
Here it is
Hello, yes, sir.
per unit time now, sir.
Yes,
Even
it is
we
per
can-
unit, not
Per
frequency.
minute also we can define.
See, frequency is number of revolutions in unit time. So unit of time is second. So number of revolutions in 1 second.
The frequency means always per second we should define.
Didn't get you.
The frequency means number of revolutions always per second or per minute also we can say that per hour like that.
Per second, per minute, it may be given, but SI unit will be in second. Number of revolutions per second is SI unit, and which is called hertz. Okay, that will be called hertz. Number of revolutions per minute, that will be called RPM, rotations per minute.
Sir, copy it.
Copy.
Sir, copy.
Now next is angular acceleration. So what is angular acceleration? Angular acceleration, same as in velocity, we will differentiate the angular displacement twice. D square theta by dt square.
Sir, copy it, sir.
Copy. circular motion. Circular motion is of two types, uniform circular motion and non-uniform circular motion. In uniform circular motion, omega or angular velocity is constant. But in non-uniform circular motion, omega will not be constant. Here speed will be variable. Okay. And in constant circular motion, speed will be constant, like constantly moving fan. And here example is pendulum.
Sir, copy.
Copy. Now, general equations of circular motion. What are the general equations of circular motion? See, in circular motion, if angular acceleration is constant, then what we can do? Then we can use the equations of motion as we did in case of kinematics. Okay, here also we can use same set of equations, but just the terms will be different now. Initial velocity will be initial angular velocity, final velocity will be final angular velocity, acceleration will become angular acceleration, and displacement will become angle covered. That's it.
So we can only use them when both are alpha is constant.
Yes.
Sir, copy.
Copy. Yes, now see this question and try solve it.
I am rotating 60 rotations per minute. Sir, RPM means rotations per minute machine.
Yes.
Substance, V puts to use and V put duplicating. V and the domain is domain U plus alpha T 0 to 360 minus alpha into T. 20 seconds, so we get alpha T 80. certainly. If you convert into radian per second on 18 RPM per second. 18 minus కదా. So here we need to figure alpha AK na AK mention alpha. So 3600 we can get as a number of revolutions. So we get 3600. 1600 revolutions. Sir, hello sir. Hello sir. Hello sir. Amma. Amma.